All right, so when we look at these graphs, if you put into your calculator, I think it's a very simple graph that you can see and you can draw. And what you find out with all of these graphs, what shapes are they? They're all circles, right? So let me go ahead and plot these circles really quickly. So you have a circle right here. Okay. Now, let me make this a little bit better. All right, there we go. So this would be a 2 cosine theta. 3 cosine theta would look like this. Okay, so the most farther out would be at r equals to 3. Okay, and now just look at these two values. Just look at these two circles. What can you say they share in common? What do they both share in common? They're both circles, and they're what? Pi radians. Well, you mean the circumference?
Yeah, they have the same proportion.
I see if you can formulate it better. Anything else in common, like something pretty obvious? They both what? They both go through the origin. That's very good. They both go through the origin. Let's make a point over there. All right. So they both go through the origin. Yes, they do. Anything else? Yes. Yeah, they are on the x-axis. You can say, hey, can you see the diameter? It's on the x-axis. I think that's pretty special. Okay. And what else? I think something else is also very special here. Yeah, the number next to the cosine, it's when you say size, what do you mean the size? The diameter, right? So you can say, oh, hey, what's the diameter here? It's 2. Oh, how do you know? Well, that's a 2 right there. Now, so what we will do, okay, we will do some graphing, and we'll do the graphing without a calculator. But first, I want you to use a calculator to see the graphs first, okay? Now, let me just ask you a few things here. We're going to do the sine and cosine, but before we do the sine cosine, like in depth, I want you to acknowledge one simple fact that we have done for a long time. But I want to make sure that everyone is understanding it clearly. So if you look at sine theta and cosine theta, if you look at sine theta and cosine theta, I want you to write it at the top of the page. We know that these two functions, they fluctuate between two integers, two values. What are the two values that these functions are fluctuating in between? Sine could be, sine and cosine could be as great as what number? No, that's a theta. I'm saying sine theta could be as great as one, right? Sine and cosine theta, they could be as great as 1. Cannot go more than 1, right? It's nonsense that it goes over 1 because when we say sine theta, it's opposite over hypotenuse. There's no way that it can go over 1 because there's no way the opposite side is longer than the hypotenuse. And what about the smallest value? Not 0, not 1/2, -1, right? -1. Now, I want to make sure that you are extracting these values, these simple values, like sine theta could be 1, cosine theta could be 1, it could be -1 as well, it could be 0, it could be 1/2. You know all those nice numbers. And the fact that you know these nice numbers would help you tremendously when you do the plotting, polar graphing here. So now you're like, oh yeah, we have a point right here. Okay, for this very first graph, we have a point right here. Why do we have a point right here? Well, because think about this. When theta is equal to 0. But what's cosine 0? 1. 1 times 2? 2. That's why you have the point right here. Okay, that's why. What about pi over 2? When theta is pi over 2, cosine pi over 2 is 0. So that's why you have this point right here at the origin. Okay. Now, something special about these two circles is that, hey, can you see the quadrants that these circles are occupying? They're only occupying quadrants 1 and quadrants 4. Why is that? Now, I really hope that you are asking these why questions so that you can have a better analytical lens to look at the shape, not just, oh, I'm going to go ahead and memorize them. No, it's not good if you just memorize it. It's almost impossible to memorize them. Learn how to analyze them. Like, how come it's only quadrants 1 and quadrants 4? What happens when it's over quadrants 2? Well, let's think about this. Let's just think about this. If we say, let me come up with a nice value. Let's say 2 pi over 3. What's cosine of 2 pi over 3? It is 1/2. 1/2 times 2 is? No, actually, no. It's negative 1/2. Sorry. Cosine of 2 pi over 3, it's negative 1/2. And negative 1/2 times 2 gives you negative 1. Now, let me go ahead and use purple color for this so they can see better. Okay, let me use purple color here. So where is that point on this graph when the r is negative 1? What do we say about r being negative? You go the opposite direction, right? So if you think about 2 pi over 3, it should be along this line, okay, roughly that line. Like if you have a positive value, then you put a point right here, if you have a positive value. But we don't. We have a negative 1 value. So it's actually somewhere right here. So that's the reason why we are graphing stuff on quadrants 4, because when the angle is in quadrants 2, it's a negative r. Now, here's the thing I want you to try to do on your calculator as well. Now, remember we did all the tracing stuff last week with parametric equations? Well, let's do the same thing. Let's go ahead and do the trace, and let's try to observe how the graph is going when we go from 0 radians and we keep going up. So you can see how it's going in quadrants 1, and then you're getting closer to pi over 2. So you're going to 0. And then after pi over 2, you are going to, well, it's in quadrant 4, but the angle is actually in quadrant 2. Well, why? Because if you look at this, your radius, your r value, it's negative. That's why it is running around in quadrants 4 due to the negative r value. And what you can see here, it's right around 1 pi value, 3.1 radian. It heads back to the origin. I mean, it heads back to the starting point, which is 2, 0 in this case. Okay, so that's how you have a circle. So it only takes 0 to pi to go all around the circle. And if you keep going from pi to 2 pi, you are just making the same circle run again. So that's how we analyze these graphs. Okay, so you have circles for just simple number times cosine function. Now, if you have the negative, what is going to happen when you have a negative? Well, it's almost the same thing, except that the circle is going to go to the opposite direction, because when theta is equal to 0, what's r? or it's equal to -3. So that's why your very first point when theta is 0, it's over here, not the right-hand side. So everything could be explained. And I want you to understand that a graph is a reflection of points. Whatever points you have, that's what the graph is showing. So these are the cosine graphs. And if you have the sine graphs, then you should have something very similar, except that the graphs would look like this. Okay. The graphs would look like this. And the graphs would look like this. So we say, hey guys, look at these sine graphs. What do they all share in common? Compared to the cosine graphs up there, what's something very special? Yeah, wait, hold on a second. The y-axis, right? So you can say that, hey, for these circles, all right, for these circles, the diameter, it's along the y-axis. Okay, for cosine, diameter, it's along the x-axis. Okay, so that's something you can observe. So they're all circles. They're all circles. And the farthest away from the origin is going to be the number in front of the sine and cosine, because that will dictate how big the r is. So they are all circles. And let's summarize all the circle stuff right here. So how do you know it's a circle when you take a quick glance at the unit circle? Oh, no, not your circle. I mean the polar equations. We say, well, if you see something like this or this, simple, a number times the sine function or cosine function, hey, that's your circle right there. If it's cosine, then you know the diameter will align on the x-axis. It will always pass through the origin. They all pass through the origin. It's just that what is the alignment? Okay, where will their diameters align? That would be the question. All right, now, what I want you to do for the next 6 graphs is this. I want you to do this. All right, first, I want you to do this as a group. Okay, so these two vertically as a group. And in addition to graphing, I need you to write down a very crucial information. Some crucial information here. I want you to write down maximum R and minimum R. And also write down what theta will these radii occur. Okay, so take a moment to plot these graphs, okay, with the calculator.